Good afternoon. Hope you guys are having a great day. At this point, you guys should have your guided notes out for section 7-8 and follow along. You guys know the rules. Don't work ahead. Stay with us and fill them in as we go. Alrighty. Well, we're going to be doing section 7-8, which is curve fitting with exponential and logarithmic models. And we have done this exact same thing, curve fitting, but we've done it with linear, quadratic, cubic, quartic models, but we have not done it with exponential and logarithmic. But the process is very, very, very similar. So it says analyzing data values can identify a pattern or repeating relationship between two quantities. Look at the table. For the values of the exponential function, f of x equals 2 to the 3x. Now, hopefully you guys are looking at this and saying, is this a growth or decay? It's a growth because this is number 3 is bigger than 1. And what is the y-intercept? The y-intercept would be 2. So you can see that in the table of values, the y-intercept is 2. And as we continue down our x-axis, the values get bigger. So it is an exponential growth. Okay, so what we need to do is we need to look at this and we need to try to determine if this is exponential if you didn't know the equation. So suppose we didn't know the equation, we just had this chart. How would we know if it was exponential? Well, you might remember when we did it for linear and quadratic, we found the first and second differences, and we always started over here and we did this minus this, this minus this. Well, that's if you have linear, quadratic, cubic, quartic. This we're asking, is it exponential? So to determine if it's exponential, you look at this and you say, okay, what is 54 divided by 18? And 54 divided by 18 is 3. And then you say, what is 18 divided by 6? It's 3. 6 divided by 2, it's 3. 2 divided by 2/3 is also 3. Okay? So notice that the ratio of each y value in the previous one is constant. They're all 3. It says each value is 3 times the one before it. So the ratio of the function values is constant for equally spaced x values. This data can fit an exponential function. So this is in the form f of x equals a b to the x. This value here is going to be your b value. So this ratio goes right here in b, which is 3. This value a is, remember, that's your y-intercept, so you can see that's 2. So even if we didn't know the original function, we could derive it because we know the ratio is 3, that goes here, y-intercept is 2, goes here. So 2 times 3 to the x. All right? Okay, so the first part of your homework is going to ask you to determine whether f is an exponential function. If so, find that constant ratio. Okay? So here's my first chart. So it wants to know, is it exponential? If it's exponential, remember you're going to divide this by this. So you're going to take 12 and you're going to divide it by 8. 12 divided by 8 is 1.5. Then you're going to do 8 divided by 5. And 8 divided by 5 is 1.6. 5 divided by 3. That's 1.6 repeating. And 3 divided by 2. Well, that's 1.5. So, since these values are not constant, they are not constant. If they are not constant, then it is not exponential. Okay. Questions on A? I don't know why I said that. I'm not there to answer you. Anyway, let's try B. Once again, is this an exponential model? So once again, you're going to start here and go 81 divided by 54. So what is 81 divided by 54? 1.5. What is 54 divided by 36? 1.5. What is 36 divided by 24? 1.5. And 24 divided by 16, 1.5. So since all of these are constant, then this does represent an exponential model. So it is exponential. And the constant is 1.5. Because it asked us if it's constant, what is the, if it's exponential, what is the constant? Okay, so first part of your homework, pretty simple tonight, just looking at these tables and determining if it is exponential. Remember, for exponential, you start here and divide. If you want to know linear, quadratic, cubic, you start here and subtract. Okay, the next part talks about doing regressions. And we have done regressions in both chapter 2, we did linear regressions, and then in chapter 5 we did quadratic, cubic, quartic, and so on. Okay, well we can also do exponential regressions. In a few minutes we'll learn logarithmic regressions to find a set of, to find a model that represents a set of data. Once you know that the data is exponential, you can use an exponential regression on your calculator to find the function. Okay, it will always fit the form a b to the x. Don't forget, on your graphing calculators, if you do not get the r² value, you have to go to second catalog, go down to D, and turn your diagnostics on. So again, if you don't get the r² value, second catalog, down to D, turn diagnostics on, hit enter, and then your r² value will appear. Okay, on this calculator part, what I'm going to ask that you guys do is, if at any point you are not with the video and you're behind the video, you need to ask for it to be paused, help each other out to get caught back up. Okay, so it's going to be really important that you just let us know if you need it to pause to get caught up to where we are. Okay, one thing about these models that's different from chapter 5, it will always tell us what type of model it wants you to find. So you have to read it. It will either say find an exponential model or find a logarithmic model. In this case, it says find an exponential model. Then it goes on to say use the model to predict when the tuition at UT Austin will be $6,000. So you have two things to do. Find the model, that means write the equation, and tell me how long it will be for you to get for the tuition to be $6,000. And then it also says let x correspond to 1999-2000 school year. So x equals 0 is here. This would be 1, 2, 3, and 4. So here's your list 1, here's your list 2. So we're going to go to our calculator, stat, edit. And then remember, we need to clear these lists, don't delete them, clear them, up, clear down, over, up, clear down. So you're clearing your lists out. And now list 1 is going to be your year, so you're just going to type those in, 0, 1, 2, 3, 4. And then list 2 is 31, 28, 35, 35. Just going to double check that I got these entered right. Okay, perfect. Okay. So once we get our list entered, remember we go second, quit, so go home. And now you're going to go to stat, and we're going to go over to calculate. And you're going to go down. You can see we had our linear regression was number 4, quadratic regression was 5, cubic regression is 6, quartic regression is 7. But if you keep going past 7, you see exponential regression is down at 10 or at 0. So exponential regression is what you want. So you have stat, calc, exponential regression. Hit enter again. Okay, so this is what you have. Again, if you need time, you got to let us know, and they will pause the video and get you guys caught up. All right, it tells you that the formula is y equals ab to the x. So it's telling you y, or f of x, is equal to ab to the x. There's your formula. And then it gives you a, and it gives you b. So you just plug in. So the value of a is 3,235.64. Okay, times the b value is 1.07 to the x. And this makes sense, 1.07, because it's an exponential growth. So that is a value that is greater than 1. So there's your model. Y equals 3,235.64 times 1.07 to the x power. So that's part 1. The next part says, okay, so now we want to use this model to figure out when the tuition will be 6,000. So you need to ask yourself, is tuition x or y? Hopefully you guys are saying tuition is y. So y equals 6,000. What is x? Okay, so what do? Hopefully you're remembering, we go into our calculator and we need to graph all of this. So we're going to go to y equals, clear out anything we have. Now what do we have to do before we can paste this regression equation? Hopefully you're saying, got to get that plot turned on. So up, turn the plot on, come down. So you've got to turn your scatter plot on because we enter data into our list. Now in y1 we need this regression equation, and we're not just going to type it in because it wasn't exactly these values and we want to use the exact values. So how do we get that again? Hopefully you guys are saying we go to VARs, statistics, equation, enter. That was VARs, statistics, equation, enter. And then in for y2 we need to put 6,000. So to start, I'm going to do zoom, and we're not going to do zoom 6. Remember, that's our standard window, negative 10, 10, 1, and we know we've got numbers way bigger than negative 10, 10, 1 by a scale of 1. So we're going to do zoom, and remember you got to go down to 9, which is statistics. So you're going to go down to zoom stats, enter. Okay, the only thing is we're not seeing our 6,000. So let's take a look at what our window looks like. So if you notice, the y max value is 4,368, and we graphed y equals 6,000. So this max value for y needs to be something bigger than 6,000. It needs to be 6,500, just anything a little bit bigger. And I'm going to go by a scale of 500s. Here's my first window. I'll give this one an attempt and see what my graph looks like. Okay, so far you can see we now have our constant, we have our exponential growth regression here, but we don't have the point of intersection. So we need to expand this window. And notice down here these little dots, your x scale is by 1, and it only goes to 4.4. So this is 1, 2, 3, 4. So we need to go a little bit further. So let's change our window, and let's try an x max value of 10. So here's my final window, and then I'm going to graph it. So here's my graph. Alright, well, we need to find this point right here where they intersect. So what do? So you guys are saying second calc, intersect. Again, that was second calc, intersect. Now, is the first curve the exponential curve? Yes, hit enter. is the second curve, the constant curve. Yes, hit enter. Now this one, it only intersects at one point, so we can just hit enter again. So we can go enter, enter, enter. And you should see that the tuition will be $6,000 sometime in 9.07 years. So it's in 9.07 years, but you got to be careful because it asks when. And usually when they ask when, they want a year. So 9.7 years, you got to figure out with your chart, if it's 9 years past this, it'll be sometime during the year, school year 2008, 2009. Oops, sorry here. 2008 to 2009. So somewhere in this time period will be where our, when the tuition is $6,000. Okay, so example 2 is done. Again, if you have any questions, help each other out with this. Okay, the next part talks about logarithmic regression. And logarithmic regression, a lot of times our calculators, and your graphing calculators are definitely this case, where they use natural log regression. And that's fine, it's just a different base, but it still is a logarithmic regression. It's just base E instead of base 10. So our calculator does have natural log regression. If you happen to notice that when you went to Stat Calc and down here, let's see, we had exponential regression was 10, but right above it was the natural log regression or logarithmic regression. So here's your logarithmic regression, here's your exponential regression. Don't forget I told you that every single problem will tell you what type of regression to run. So it says use logarithmic regression. So it's telling you what type it wants you to find. And it says use a logarithmic regression to find a function that models this data. So the first thing we got to do is find our regression equation. So we're going to go back to our calculator. We're going to go back to Stats, Edit, clear these lists. Okay. And you guys can see the whole chart because my calculator is blocking the part of it over here. So it is 1, 2, okay, I'm just going to double check my data, make sure I got it in correctly. Okay, I always like to check to make sure I've entered my data correctly. So I've got everything entered correctly. Go home. Again, we go back to Stat, Calculate, and instead of going all the way down to 10, I'm going to scroll up and it'll wrap me back around a little bit faster. And you see right here at number 9 is logarithmic regression. So go ahead and hit enter. Enter. Now it shows you your model is y equals a plus b natural log of x. Again, a plus b natural log of x. Here's a, here's b, so let's fill it in. We get y equals, and then you have a, which is 0.59, 0.59 rounded, so 0.59 plus the natural log, oops, I missed b, hang on a second, erase this, okay, plus b times the natural log of x. So b was 2.63, so it's 0.59 plus 2.63 natural log of x. Y equals a plus b natural log of x. So here's my formula. Okay? All right, then the next part says, when will the speed reach 8 meters per second. So 8 is your speed, which is y. So they're saying y is 8. How long does it take us to get to that speed? So when will it reach it? So that's x. So once again, we're going to go back to our calculator, go to y equals, clear everything out. Bars, stats, equation, enter. Again, that was go to y equals, vars, stats, equation, enter. And remember, in order to paste this regression equation, you have to have the regression on your home screen. So your home screen has to have that regression in order for it to paste. It will paste whatever the regression is on your home screen. Okay, and then we're going to go down to y2, and in y2 we're going to put 8. Okay, now we need to go to zoom because this was on our one from last example, and we're going to go back to zoom 9, which is stat. But once again, we do not see our constant 8, so we need to go to our window and say, well, the maximum y value is 6.4, so we need to go down and make this something bigger than 6.4, like 10. I'm going to go by a scale of 1. Graph. And once again, we can see we're not quite getting to our x value, so we're going to change this x value. And this is just something you have to mess around with until you get those two to intersect. So I'm going to say, let's change it to 20. And I'm going to go by a scale of 2. So here is my new window. And graph. So here's the scale that I ended up using. Alright, well, once again, we need to find this point of intersection. So second, calc, intersect, enter, enter, enter. First curve, yep. Second curve, yep. Yes, yep. And you can see that it is 8 at 16.9. 16.9, and that units for that time was minutes. So it is 16.9 minutes. Alright, well, still not done. It then says, okay, so what will the speed be in 15 minutes? So time was x. So now they're saying when x is 15, what is y? Well, once again, we go back to our calculator, and what do? Hopefully you guys remember, you do second calc value. So that one's going to be second calc value. Your calculator's sitting here blinking. What do you want me to let x be? And we're going to let x be 15. And we know we're good on our window because we changed that x max to 20. Remember, sometimes you have to fix that if it's less than 15. Okay, so I say when x is 15, what's y? And y is 7.73. So it is 7.73, and then your units were, that was speed, so it was meters per second. Okay. All right, well, hopefully you guys were able to help each other out. I need you guys to work with each other and help each other out with this as you have questions. I know there's people around you that can answer them. So go ahead and start your homework and have an awesome rest of your day.